welcome back.
Hi.
How are you doing?
Good.
Good. So last time we were together, we started talking about ratios and proportions. Fractions, and then those fractions equaling each other. Today we're going to use that exact same concept, this ratio and this proportion, in order to help us identify if some shapes that we have in front of us are similar. Let's talk about what we mean in a geometric sense for shapes to be similar. Similar polygons have the same shape, but not the same size. They're similar if and only if their angles are congruent and their sides are proportional. But they have to be the corresponding angles and the corresponding sides. Let's look at these next figures, and we'll see what we mean by corresponding angles, corresponding sides. So I have these two shapes, ABCD and WXYZ. And I'm told that ABCD is similar to WXYZ. This is the symbol for is similar to. So when I ask you to write a similarity statement, use the symbol. It'll save you some words. Notice in these names that A and W are both listed first. This means those corners are corresponding. And since corresponding angles are congruent, I can write that angle A is congruent to angle W. Whatever I've got there. B comes next, and so B corresponds to X. C is written third, which means C corresponds with Y, which is written third, and so angle C is congruent to angle Y. Can you see which corner is left for corresponding? D and Z are the last corners left. They have to be corresponding. Okay? Not too confusing? Not too confusing? All right. Looking at these corresponding sides, we want the sides that are created by the corresponding corners. Okay? So this side up here, which is created by the corners A and B, is going to correspond to the side that's created by, well, A corresponds with W and B corresponds with X. So it's the side WX. And that same pattern happens all the way across. All right? So what would I write here? And here? And here? Perfect. This is called the scale factor. And it's what you would need to multiply to one of the shapes in order to get the other one. All right, we're going to practice finding those corresponding corners, writing the corresponding angles congruent, finding the proportion for those corresponding sides, and calculating a scale factor. Let's look at number 1. We're going to list all the pairs of congruent angles. And then we're going to write a proportion for all of the corresponding sides. All right, we've got the shape DEF, similar to triangle GHJ. We're told that D corresponds with G, E corresponds with H, and F corresponds with J. Okay? That came directly from the order of the name. The corners are all angles, and the corresponding angles are congruent. That means the pink angles are congruent, the blue angles are congruent, and the green ones are congruent. Angle D is congruent to angle G. Angle E is congruent to angle H. Angle F is congruent to angle J. Good job. There's your pairs of corresponding angles. Now we need to write the proportion for the sides being in proportion. So I'm going to look at side DE. DE corresponds to GH. So I'm going to write those two in a fraction. And those equal EF in a fraction with HJ. Now notice something here. All the stuff about one triangle is living in the numerators. And all the stuff about the other triangle is living in the denominators. Please try not to mix those up. And those are the proportion for our sides. Okay, easy enough? Order matters. Be very particular about the order you're writing things in now. Because if you mess up the order of things corresponding to each other, I'm not going to be able to give you credit. They have to be corresponding, okay? Let's look at number 3. We'll leave number 2 for another day. Determine whether each pair of figures are similar. If they are, we're going to write that similarity statement, that shape is similar to shape. And if they're not, we're going to explain why. Bless you. Let's look at 3. We have 2 things to check. We have to check to see if we have congruent angles. And then we've got to check if we can get some proportional sides. Are the angles congruent? I don't mean within the same shape. I mean from one shape to the other. Are all the angles congruent? I'm going to start at A. Starting at A, is A congruent to G? The angles. See this little marking right here? Yes. Those angles are congruent. What about those two? Are they congruent? Okay, so far so good. These two, are they congruent? The green ones? Or the blue ones? Yes. And these two? No, because angle K is not marked to be congruent with angle D. So I don't know for sure if they're congruent or not. In addition, that's a 90. None of the others are marked as 90. I don't know what the measures of the other ones are. But they might not be 90, and so I can't assume that they are unless it's marked that way. So we don't have congruent angles. Since we don't have congruent angles, there's no need to look for proportional sides. And we'll write that shape A, B, C, D, E is not similar to G, H, J, K, L. And here's our reason. Angles aren't congruent. Put it away. Let's look at number 4. Same idea. We've got two shapes. Now we have triangle PQR and triangle QST. Triangle or point P, we're going to look at that angle. Well, it's congruent to itself, right? We get that one for free. I'm going to zoom in really close on those triangles. Do you see those little tiny arcs in there, those little tiny markings? This one has 3. This one also has 3. That means they're the same size. This one has 2 and this one has 2, which means all the angles are congruent to each other. This thing might be similar. At the very least, we've got congruent angles. So that was our first check. What was our second check? Yeah, proportional sides. All right, so we've got to check to see if we can write these sides measures in fractions, that when we reduce those fractions down, they all end up being the same fraction. QR and ST are right now the easiest sides for me to deal with, right? Because they've got numbers. The other ones don't have numbers, so I don't know what to do yet. It's 11 over 22, or 1/2. All right, let's look at some of these other sides. I'm going to look at PR and PT. I don't have measures, but I know that they're congruent to each other, right? I know PR is congruent to RT. They have the same number of little dashes. So I can just kind of make up a number to put in there that I like, that's easy for me to work with. 3. Okay, so this is 3 and this is 3. So now we're going to set up our proportion. PR to PT. PR is 3, but PT is 3 plus 3. 3 over 6 reduces down to? It's the same thing. Look at the other side of that triangle. PQ, PS. Same argument, right? It's the same setup. I've got two things that are congruent over there. I can put in, again, any number I wanted, or the same. I could put it as 3. And I'd end up with the exact same fraction, yes? So my sides are proportional. This means triangle PQR is similar to order matters. P is the same point, so it corresponds to itself. Along this side, I have Q and I have S. So Q must come next, which means S must come next. That means T comes after that, and there is my similarity statement. We were also asked to find the scale factor. What's the scale factor? The 1/2, yes. The fraction you get when you look at those sides. This is my scale factor. Very good. Join me on the back of the page when you're ready. Top of the page. Now that we know how to show this thing is a similar polygon, and we can do that very well now, we can start talking about what happens when we look at the perimeter. So 2 polygons are similar, allows us to say that the perimeters of those polygons will be proportional to the scale factor between those 2 shapes. So if I knew the measures of the sides of those other 2 triangles, I could grab the perimeter of one, divide it by the perimeter of the other, and that fraction should be the same as that scale factor that I just calculated. Okay? Looks like this. Here's this shape. There's the perimeter. Here's this shape. There's the perimeter. There's only one thing that makes this work, though. Okay? See how in this case the perimeter for that shape is in the bottom? Ethan, you with me? In the scale factor, you have to make sure that information about that shape is also in the bottom. Okay? So you've got to get these to match so that it works out. In this case, that one would be AB. Okay? Let's practice all of this and sum it up. Let's look at number 6. Here I have some trapezoids. Happy little trapezoids. These 2 sides correspond, and these 2 sides correspond, and these 2 sides correspond, and the other 2 sides correspond. Trying to solve for x, what we need to do is set up a proportion. Okay? I'm going to set up a fraction between these 2 sets of things. Let's set up this way. Notice, I have the information about the corresponding sides in one fraction. Notice, I have information about the same polygon in the same location of my fraction. This polygon's information all lives in the numerator. This polygon's fraction all lives in the denominator. In this case, you could totally set it up the other way around. Okay? That's how I set this one up. Cross multiply, solve. Right? All right, let's do it. Cross multiply, I get 10x equals, I need help with 4.5 times 5. It's going to be bigger than 20, but I don't know how much. 22.5, okay. And then I'm going to divide both sides by 10. That one I can do. There's the value of x. This is exactly what you were doing yesterday. What we've added is you having to interpret the shape to set up the information. So far, so good? Yep. All right. Join me at the bottom, number 9. We're told that these 2 shapes are similar to each other. We've been asked to find the scale factor of ABCD to PQRS. I'm going to pause there for a second because of how this is written. ABCD to PQRS is the same as ABCD to PQRS, which as a fraction, I can write ABCD over PQRS. This means anytime I'm setting up those fractions, I need to put information about ABCD on top of the information from PQRS because the problem told me to set it up that way. All right? All right. After I'm done finding that scale factor, I've been asked to find the perimeter of each polygon. All right. Zooming out again so we can see our picture. ABCD, PQRS. 20 is up here. These two sides are congruent, so this is also 20. Now, I know it looks like these two sides are congruent, but they're clearly not because they have different measures. And so you have to imagine that this is like a different figure altogether. Okay? It looks like I'm trying to make it look like a squiggle. Almost like a Z, but not really. Because I can't, once I like put more than 3 tick marks, I have trouble like seeing how many tick marks I have there. So I have 1, 2, 3, and then squiggle, which kind of looks like a Z, just so it looks different. Okay? Yep. This side over here is congruent. To find your scale factor, you're going to do side divided by side. We want side information for ABCD. Looking at these two, I see these are the ones that are corresponding. Because in our name, ABCD, PQRS, A and P are both said first. B and Q are both said second, and so on. Those are the sides I'm going to use. And I just need to reduce this scale factor. 4/5, she says. All right, we're halfway done. Scale factor, done. But now I need perimeters. I can get perimeter for ABCD, yes? Just add the sides. 20 plus 14 plus 20 plus 14. Calculator. 68. We did 20 plus 14 plus 20 plus 14. I don't know what this perimeter is. But at the top of this page, perimeter of similar polygons says that I can take the two perimeters, write them as a ratio, and that ratio is equal to my scale factor. That is the ratio of the sides. Perimeter 1 is 68. Perimeter 2 is the one I'm looking for. My scale factor is 4/5. Yes, ma'am. She said cross multiply. 68 times 5. It's 40?
No, not 40 like.
Oh, there's going to be 40 in it. Because 8 times 5 is 40? Okay.
170.
170? 273? 272. Did you do 68 times 5? It's 340. We were all wrong. Thank you for double checking on that. I don't have a calculator up here, and multiplying big numbers hurts my head, so I wait for y'all to shout numbers at me, and when someone sounds like they know what they're talking about, or there's a calculator in their hand, I'm like, yes. All right, 4 times p. Now what? Divide by 4, and p equals 68, but 68 was the other perimeter. I'm sorry, P2, I guess what we're looking at. 85? All right, I'll believe you. It seems reasonable because the perimeter is bigger than the original perimeter, and this shape is bigger than the other shape, so sure, I'll go with it.
Yeah, it's 85.
It's 85. Okay, she just confirmed. Good. Not terrible? All right. Turn them in. Turn them in. Now, a little while ago, we were discussing what all we needed to do in order to confirm that these shapes were similar. We had to show all the angles were congruent, and we had to show that all the sides were parallel or proportional. Triangles allow us shortcuts. I like shortcuts. It means I don't have to do so much work. With a triangle, all I have to do is show that I have 2 pairs of congruent angles, and I can say they're similar. Okay? Right? On a triangle, all I have to do is show that 3 of the sides are proportional, and then they're similar. I don't have to deal with the angles on triangles. I can just look at the sides being proportional. Or I can do side angle side, not angle side side. We're talking about if we've got a triangle, we're talking 2 sides and the angle that those 2 sides create. Side, angle, side. You're looking for those sides to be proportional between the 2 triangles, and these angles in here to be congruent between the 2 triangles. That's enough to say that the triangles are similar. Let's practice. I'd like to practice with number 10. What do I have? What do you see? Beautiful, you got 2 triangles. What do you notice about the triangles? I've got some things congruent. Can you be specific and tell me which angles are congruent? Angle B and angle E. Angle A and angle D. Beautiful. Which would mean that C and F are congruent. I heard you say that too. Yes, but shortcut. We don't need all 3 angles for similarity. We only need 2. So because angle B is congruent to angle E, and angle A is congruent to angle D, that's 2 of my 3 angles, these triangles are congruent. Wait, order is important. Corresponding angles have to be written in the same order. B corresponds with E. I wrote B second in this triangle's name, which means I have to write E second in this triangle's name. A corresponds to D, and I wrote A first, which means I have to write D first. And so my next triangle's name must be DEF. Did you see how I did that? Okay. General questions.
That's it.
This is where I'm going to stop today. We'll see you back on Monday.